Hello, my name is Dr. Russell T. Warren, and I am the author of Statistics for the Social Sciences, a General Linear Model Approach, published in 2018 by Cambridge University Press. I'm here to teach you briefly about the General Linear Model. The General Linear Model, or GLM, is like this set of Russian Matryoshka dolls. You may have seen a set of dolls like these before. These dolls are nested so that each doll can fit inside the next largest doll successively until all of them can fit inside one another within the largest doll. The GLM functions the same way. Each statistical procedure within the GLM is a special, more specific version of a broader statistical test. The most basic test is the z-test, which requires interval or ratio level data, a known population mean, and a known population standard deviation. This is just a more specific version of a one-sample t-test, which requires interval or ratio level data and a known population mean. If you perform a one-sample t-test and know the population standard deviation, the procedure simplifies to being exactly the same as a z-test. In statistics language, we say that a z-test is a special case of a one-sample t-test. The one-sample t-test is, in turn, a special case of an unpaired two-sample t-test. This is because a one-sample t-test is just a two-sample t-test where one of the samples is the population mean. The next most complex procedure in the GLM is analysis of variance, or ANOVA. Because ANOVA is a broader procedure that includes the unpaired two-sample t-test, we say that it is a generalization. In statistics, generalizations are statistical procedures that can be applied to a broader set of situations or more types of data. ANOVA is a generalization of an unpaired two-sample t-test because ANOVA compares the means of three or more groups instead of two groups. If you perform an ANOVA with two groups, you'll get the same results as a two-sample t-test. A generalization of ANOVA is correlation and regression. These procedures examine the correlation between two interval or ratio level variables. This means that ANOVA and all of the special cases within it merely investigate the correlation between an independent and dependent variable. The only difference is that in ANOVA, the independent variable is a nominal variable that splits the data into three or more groups. Correlation and regression are a special case of multiple regression because multiple regression investigates the relationship between one or more independent variables and a dependent variable. The GLM is a great framework for understanding statistics because it means that all statistical procedures are interrelated and based on the same logic of null hypothesis statistical significance testing. Therefore, if you understand one procedure, it is easier to understand other procedures because newer procedures are adaptations of a statistical method you have probably already learned. This video is just a brief introduction to the GLM. My textbook explains all of these interrelationships with much more detail. Also, the analogy of Matryoshka dolls breaks down because statistical methods have multiple special cases that apply to specific situations. You should be aware that there are many other GLM procedures that I have not mentioned. Thanks for watching this video. I hope you learned something about the General Linear Model and that this framework makes learning specific statistical procedures easier to master. And please check out my textbook, Statistics for the Social Sciences, a General Linear Model Approach, published by Cambridge University Press.